Welcome to the traffic simulation tutorial. So in the previous unit, we covered different applications of traffic simulation tools. And in this unit, we will use one of these tools, a tool called PTV Vism, and together we will develop a very simple T-junction adapted to the Cambodian context, which is where I'm currently speaking to you from. And we will do this using the free student version, and shortly I will show you how and where you can download this. And this particular tool is very rich in features. We'll only really scratch the surface, and I highly recommend you do exactly as I do. And then after the tutorial, if you wish to continue experimenting with this tool, please go ahead. I will also point you towards useful resources. And in this tutorial, we will go through the following 10 steps. I won't read them out, but I'll put them up here on screen. Essentially, we will show you how you can download and install the software, then how you can build a network and then adapt it to an emerging city context, in this case, the Cambodian context. And then at the end, we will also mention things that we could have done that we didn't do in this particular tutorial. And please note, unfortunately, Vism only works on the Windows and Linux operating systems and not on a Mac operating system. So if you are using a Mac, you will not be able to download and install the tool. If that is the case, I do recommend you still watch the tutorial video to get an understanding of how the tool works. And then at some point in the future, when you do have access to a Windows or Linux machine, you can then complete the tutorial. I also highly recommend you use a mouse with a scroll wheel preferably, and you will see why shortly. And if you can, also use 2 monitors, one for the tutorial video and one for running the software. Alternatively, if you have a tablet, you could watch the tutorial video on the tablet and run the software on your computer or laptop. Of course, this is just to make it more comfortable. You can switch between windows and play and pause the tutorial video. And also, as I go about the tutorial, I will be generating different project files, which I've also uploaded below. So if you are not able to follow along, you can download and open these files to catch up to where we are in the tutorial. So with that, over to step 1. So step 1, we need to download the PTV Vism student version. So for this, open a browser of your choosing and go to ptvgroup.com. I'll also include a link below to this. Once the page opens up, go to products in the top left. You'll see Visum. We're interested in Vism. So click on Vism. And here you have the option to download a free student version. So click on that. The student version, of course, has many different limitations and features watermarks, which you will see once we open it up. And click download now. Download PTV Vism and Viswalk because both are integrated in one solution. So once you've downloaded the software package, double click on the setup Vism file to install the software. This will ask you what language you wish to install the software in. I would highly recommend you stick to English. I will do the tutorial in English, and this will make it easier for you to follow along. Then you'll be prompted to accept the end user license agreement, the data privacy statement, and then you can install the software in a location of your choosing. So install, and then we will let this install, and then we'll get started once this is done. So now that we've restarted our computer, let's open up PTV Vism 2025, the student version, for the very first time. And I anticipate if you are using a future version, say 2026 or 2027, you should still be able to follow along. I don't anticipate any changes so significant that this tutorial will be rendered obsolete. And when it does, you're greeted with the PTV Vism and PTV Viswalk start page, where you have lots of different information on the 2 different tools, as well as blog posts and topical videos. It's currently the winter season, hence the Christmassy videos. But what's most relevant for you is the support services. So if you enjoy what we do today in this unit, you can, of course, also do the first steps tutorial here. This goes into more depth than we will go into today. There's also example files, webinars, and if you were to do a more technical project, you can also receive technical support, which you can find in this start page. So I recommend you explore this page in your own time. For now, I'm going to close it and walk you through the PTV Vism graphical user interface and the various different windows we see here. And we can begin with our network editor, which is essentially our canvas where we will build our simulation. And for now, you can see a Bing map, which we can pan around using the hand here, or you can press your scroll wheel on your mouse and also pan around in this way. To zoom in, like with many mapping tools, we can roll our mouse wheel forward to zoom in, backwards to zoom out, or you can of course use the magnifying glass tool. So let's zoom into Southeast Asia, where I'm currently speaking to you from. Over here on the left, we have our network objects. So these here are all the different objects that we will use to build up our simulation. Today, we'll look at links, which are also roads, reduced speed areas, conflict areas, vehicle inputs, and vehicle routes. We could, of course, use lots of other objects, such as objects related to public transport, or if we were doing some pedestrian simulation around our vehicles, all of these objects are also here. But we'll save that for a future tutorial or perhaps a future course. And basically, you use these different objects in the network editor. And once we've built up our simulation, our digital environment, we can run a simulation, which you can do up here by pressing play. And when you press play, you can control the speed of the simulation. And essentially, while you run a simulation, Vism collects lots of data, which you can then analyze and compare with different scenarios. We won't be going into that much depth today, but again, perhaps in the future, we can revisit this. And lastly, up top here, we have different menus, which we will look at today. But for now, let's zoom in to Phnom Penh, the Cambodian capital, where I'm currently speaking to you from. So I know where it is. I can easily zoom in. It's just southeast of the Tonle Sap, the largest freshwater lake in Southeast Asia. But I don't anticipate all of you will know where it is. So up here in your network editor, you can click on Find Location, and let's type in Phnom Penh, Phnom, Phnom Penh, Cambodia. And that will take us to the city, a city along the Mekong River. And now let's zoom in to Koh Pik. It's this island here with an interesting looking development, also known as Diamond Island. Now zoom in and you can quickly see that it's quite an unusual development, to say the least. And I would like us to build a simulation of this T-junction here. To get a better look at it, I would like us to open up Google Street View. So first go to Google Maps, type in Koh Pik, K-O-H-P-I-C-H, Koh Pik. That will take us to the island. I must admit, it is quite an unusual development. You have this big gated community here with very academic sounding names: Wharton Street, Columbia Street, Harvard Street. So ignore that for now. And what I'd like us to do is to develop a T-junction simulation for Elite Road and Koh Pik Street. And to get a better feel for this space, let's begin by opening up Street View. Let's take a look at Elite Road. So we will simulate this road, one lane in either direction. There is parking here on the right. We will not be simulating that today. And these lanes are quite wide, say upwards of 4.2 meters. And we will also simulate Koh Pik Street. So let's take a look at Koh Pik Street. Here we can see there are 2 lanes on either side. They're not quite as wide, probably around 3.6 meters. So with this information, we can conclude step 3, which was to select a site and analyze the site. So with that, let's go to step 4, which is to build our network. To do this, open back up PTV Vism, zoom in to our T-junction here, and we're going to focus initially on Elite Road. So this road right here from west to east. And I will ask you to create a link, which is our first network object. And a link is essentially a road. And we're going to add this directly to the Big Map, though we could import our very own higher resolution satellite image, or perhaps a technical drawing like a DWG or CAD file. To keep things simple, we will do it straight on the Big Map. So when you click on your link, it should become highlighted in yellow, then hover back over your network editor. And now I need to point you towards a function in Visim, which might feel somewhat unusual at first. And that is control right clicking, which is something you will need to get used to because it's required for the addition of most network objects. So let's give it a try. Go to the beginning of Elite Road, or at least where the last intersection ends, and press Control, hold it down, and then right click, also hold it down and drag. Drag your road until the pedestrian crossing, and then let go. And this window will open up. Let's press cancel and try this again. Hold Control, right click, hold, drag from the intersection to the crossing, and let go. And that's how you add a link. And here in this window, you can see the different features and parameters of the link. This here is link number 1. It's our very first link. We can give it a name. So Elite Road. We can increase the number of lanes here, but as we saw, it's only a 1-lane road, so that's not necessary. Down here, there's more information on the width. So it's slightly wider than 3.5 meters. I estimate, say, 4.2 meters. And we could adjust the link behavior, what vehicles have access, etc. But we won't focus on that for now. So click OK, and we have created our first link. But as you can see, it's perfectly straight, which does not match the curvature of the road. For this, we need to add spline points. To do this, I think it's easier if we go into the wireframe view. So up here, top left in the network editor, you can toggle wireframe, which makes the asphalt invisible and gives you a better view on your link. And what we want to do is add different spline points so we can better adjust the geometry to match the actual street. So to do that, hover over the link, hold Control and right click, but this time we don't hold, and you'll see a dot appear. And this dot we can adjust in such a way that the road better meets the actual geometry. I'll add another one here, adjust ever so slightly, and so this is slightly more realistic. And one thing to note here is these arrows. This is the direction of traffic. And in Cambodia, we drive on the right, so this lane is on the right. So make sure that you are in the same direction of traffic flow. And now we need to repeat the same process for the left side lane. So we could hold Control and right click and drag and create an entirely new link, or we can right click on our existing link. This window will appear, and then down here, you will see Generate Opposite Direction. Click that. It also only has 1 lane as we saw earlier. Press OK, and we have our second link. You may also want to adjust this ever so slightly. You can, of course, add more spline points than I did, up to you. But here we have our first west to east roads along Elite Road. Let's repeat the same process now along Kopik Road. So again, consider the direction of traffic. Let's start from this crossing. Hold Control, right click, hold, drag, and pull it down to the other pedestrian crossing, not into the intersection itself. Release. And in this case, we saw there were 2 lanes. So add 2 lanes. We can call this is the north side of Kopik Road. This will be link number 3. The width, it was not as wide as along Elite Road, closer to 3.6 meters, so we can make these adjustments. Click OK, and we have ourselves a new road. Again, it was 2 lanes on either side, so we can generate the opposite direction, and there we're done. Now with link 3 and link 4 done, we need to add our final 2 links. So here we can repeat the same process, or another way you can accelerate your workflow is by hovering over, say, link 3, holding down Control, left clicking and dragging, and it will copy our link. Drop, and again, right click, generate opposite direction, 2 lanes, yes. And like we did before, let's adjust this so it better matches our road geometry. This will require adding spline points, so Control right click inside the link. So let's adjust it so it closely reflects what we are seeing on the satellite image. Okay, so I'm quite happy with that. And just note, when you hover over the links, you can see the number, and I will be referring to these numbers as we move through the tutorial. So link 1 is here, 2 is here, 3, 4, 5, and 6. Okay, so now that we've created our links for the different arms of the intersection, we need to connect them up. This is done using connectors. And before we do this, we have to understand what needs to be connected to what. So each link which leads to the intersection will have 2 options. So if you come from link 1, you can turn either left, connecting to link 4, or you can turn right, connecting to link 5. From link 6, I can go straight to link 4, or I can turn left and connect to link 2. And lastly, link 3, I can go straight to link 5, or again, I can turn to link 2. And the way we connect these up is by using the same object, so links, and we'll start here with link 1. And to create a connector, similar to drawing a link, we hold Control, right click and hold, and drag. And you will see you're creating a new link, but when you hover over where you want it to go, it will turn purple. So right now, I would like to connect up link 1 with link 5 and make sure that the triangles which show the direction of travel are going in the same direction. So when it's purple, I can pull it all the way in, but I want to keep it not right at the end, but close to the end. Let go, and here this window will pop up. Here we can add additional intermediate points to give it nicer curvature. So I will give it 5 intermediate points, and I will press OK. And here we have our very first connector. So now let's repeat this process, but this time from link 1 to link 4. So I'll zoom in ever so slightly. Control right click in link 1, drag while I'm holding Control and right click, hover over into link 4, and now it automatically adds the different spline points. Let go, and here we have our new connector. And now we have our second connector. Click OK. So that's link 1 done. So now let's repeat the process from link 6 to link 4. Hover over link 6, Control right click and drag. This is a 2-lane road meeting a 2-lane road. So from 6 to 4, let go, press OK. Now link 6 can also connect to link 2. This is going from a 2-way street to a 1-way street. So the vehicles in the left lane here will access link 2. So Control right click and drag, let go. And here we can delete one of these lanes. So there should only be 1 lane, the left lane meeting link 2. So that's now link 6. There's 2 options. per link entering the intersection, which leaves link 3. So same again, control, right click and drag, 2-lane street linking up to link 5. Okay. And the final one is from the right lane of link 3, which will link up to link 2. So we can delete one of these, delete. If you do not delete it, you will see vehicles enter and disappear. Hence why we are doing this. And this should be connected to the right link of link 3. And so our network should now look like this. We have our links and our connectors, and we can toggle off the wireframe view. So this is essentially the roads where our vehicles will enter. So this here now is our road network. I can toggle off the wireframe view to get a better look at it. And this is where our vehicles will be entering and leaving the simulation. And this here takes us to step 5. Now it's time to input vehicles. So back to our network objects, we're now going to use a new object here called vehicle inputs. So click on vehicle inputs to select it. And now we'll go back to link number 1. I can zoom in here, and vehicle inputs should be placed wherever vehicles enter the network. So in this case, it will be on link number 1, which brings vehicles into the intersection. And it should not be on link number 2, because this is a link leaving the intersection. So again, look at the arrows on your links, and vehicles, you will quickly see, can enter from only 3 different locations. So from link 1, link 6, and link 3. And again, to add our vehicle inputs, hover over link 1, press and hold Control and right click, but don't hold. And you will see a black bar appear and a list will appear. If the list didn't appear, right click on the vehicle input, the black bar that was created, and click on Show List. And these lists are quite important. They show lots of object-related information and parameters. And so here we can see for vehicle input 1, it's on Elite Road. The volume of vehicles is currently 0. Let's say, hypothetically, it's 250 vehicles which enter this space per hour. Normally, we would derive this information from traffic counts, which we covered earlier this week. And then over here, you can see your vehicle composition. This is the default composition where we have predominantly cars, over 90% cars, some light goods vehicles, some heavy goods vehicles, and their speed distribution is around 50 kilometers an hour. This actual street is slightly slower, but we'll get back to that later on. Now we also want to add our vehicle inputs for link number 3. So hold Control, right click, but don't hold. We've created a new vehicle input. This would be a busier road, let's say 500 vehicles per hour. And we can now add our final vehicle input. Control, right click on lane 6. And here, say 600 vehicles. Again, this type of information would have to come from our traffic counts, the volume, but also the vehicle composition, where we would count the different types of vehicles, which we would then reflect when building our simulation. So now with that done, this is the very first time we can actually run our simulation. And to do that, we go up here to the top and we can click play. This will prompt us to save our network. So I suggest you create a folder somewhere in your computer or on your desktop, and you save it with whatever name you choose. I will call it 1, so it's our first version file, base network and vehicle inputs. And this means that if you make a mistake later on, you can load back up this file and continue where we've left off here. So save, press OK. So congratulations, you're now running your first simulation. In my case, the vehicles are moving very fast, so press minus if you wish to slow it down. To speed it back up, hold Shift and plus. And what we see here is a 2D view of vehicles moving through our network. We can move to a 3D view by clicking on the box up here, or by holding Control and pressing D. There are watermarks because this is the student version. If you wish to pan around, hold Alt, click in your mouse wheel, and you can move through your network. And while you're doing that, I would like for you to take note of anything that might not seem realistic. For one, you may have noticed that no vehicles driving along Kopik Street are turning left or right. And that's because we haven't set our vehicle routing decisions, which we'll get to in step 6. Something else you may have noticed is the vehicles, when they enter the turns, they're not slowing down. So if I press the space bar, I can see different time steps. And down here in the quick view window, I can see different information on each individual vehicle, including their speed. So he's driving at 50 kilometers an hour into the corner, and he is slowing down somewhat, but not in a very realistic way. So we need to adjust the speeds as vehicles enter curves. And something else you may have noticed is vehicles are overlapping. They are not aware of each other, and there are no rules, no priorities yet set. So we will also get to that in a few steps' time. So let's end our simulation, click stop, exit the 2D, 3D view, and re-enter the 2D view. So now over to step 6, we need to assign our vehicle routing decisions. So in addition to the volumes we put in, we also need to indicate which direction the vehicles are going and how many are going in each direction, which is something, again, that would come from our traffic counts. But for now, we're going to do this using hypothetical data. And the object we use to do this is vehicle routes. So click on vehicle routes below vehicle inputs, hover over the network. I suggest you zoom out so you have the entire network in view. Like always, hold Control, right click, and you will see this yellow band appear. I'm still holding Control here, and I'm going to draw this yellow band. It begins with a purple bar and ends with a blue bar, and I will follow the direction the vehicles can turn in. So I'll start with the left turn. So from link 1 to link 4, and towards the end, I will left click, still holding Control though, to create this first turning option. Now let's go back close towards the purple band and now do exactly the same. So hover along, and this time for the right turn and towards the end of link 5, and now left click anywhere in the network, and we've created our first vehicle routing decision, which you should see down here in a list. So this is the vehicle routing decision number 1, which has 2 options, which you can see here on the right. If you highlight both, you can see your vehicle routing decisions. So now let's repeat the same process. Again, we only need to do this at the 3 locations where vehicles enter the network. So now hover to link 3, hold Control, right click, you don't need to hold. The yellow band will appear, and in this case, vehicles can either drive straight to link 5, or, so let's go back to the purple bar, hover along, or they can turn here onto link 2, left click, and when we're done, you can let go of Control and left click in the empty space. Now we've created our second vehicle routing decision. Now let's add our final one. It's the exact same process. Hold Control, right click. The beginning should always be purple. Vehicles here can drive straight, or, let's go back to the beginning, they can turn left onto link 2. Here we go. And now we've created 3 different routes with 6 different options. If we highlight them all, we can see all of our routing decisions. And now we need to determine how many, say, turn left or right on link 1. This can be input as a absolute number. So here we have 250 vehicles entering. We could say 150 turn left while 100 turn right. Now let's go to vehicle routing decision number 2. Again, I'm making up these numbers. This is something you would get from your traffic counts. In this case, driving straight, I presume the majority would, and this can be entered as an absolute number or as, say, a ratio or percentage. Let's say 80% go straight, while 20% make the turn. And lastly, same again, maybe in this case 70% drive straight, while 30% take a left turn. Okay, so now that we have our vehicle routing decisions, let's run a new simulation. For this, we can close our lists, press play. I suggest you save as before you do that and call it vehicle routing. So you can open up this file later on if you need to. Press save. I've already created this file, so I'll overwrite the file. And now I can press play. And now we should be able to see vehicles turning. Yes. So 80% on Kopik Road should be driving straight, 70% southbound, and a smaller percentage will be turning. So a big improvement on what we had before. And now, another issue we previously observed is vehicles overlapping. So let me try to find us an example right here. This is because the vehicles are not aware of each other, and when they enter conflict areas, they just overlap. There's no set priorities. So we can see this here if we pan around. The Audi vehicle is driving into the van, and just for your own entertainment, if you double click on a vehicle, you can enter the vehicle and be driven through the network. And once you leave the network, it will take you back to the overhead until you leave the network. Okay, so let's stop our simulation, move on to step 7, which is to manage our conflict areas. So let's go back into the 2D view because network objects cannot be modified in the 3D view. So back in our network objects, we have an object called conflict areas. Click on this and you will see Vism already knows where the conflict areas are, where vehicles can potentially overlap, but Vism does not know the rules of the road in Cambodia. So that's for us to set. And to be honest, I don't know the rules either. So I will make up my own rules here, rules I feel should make sense in the Cambodian context. And to do so, let's imagine we are a vehicle driving initially on the Kopik Road. So say I'm driving along link 6, connecting to link 4. So there's no real conflict area here. Vehicles will not overlap. The potential is for vehicles to overlap in this area, where this connector meets this connector. And I will give priority to the vehicles driving straight, not the turning vehicles. So right-click on the conflict area box. And this is sometimes an exercise of trial and error. Set B has right of way. So yes, I want B to have the right of way. So the straight driving vehicles will have the right of way. Similarly, in the southbound direction, There's potential for conflict here. Let's right click. And again, I want B to have the right of way. These vehicles will continue down here. They too should have the right of way. So again, B has the right of way. There's another conflict area here where these vehicles coming here are in conflict with the vehicles moving along Kopik Road. So B has the right of way. And I think that's good. There is another conflict area with the vehicles driving along this connector and this connector. Here, I don't know who would have priority in this case. So let's set it as undetermined. Same goes for this particular location. And if it's undetermined, basically the closest vehicle will take, not priority, but will go first. So set as undetermined. So if this is correct, we should not see vehicles overlapping anymore. So I'll go File, Save As. Let's call it file number 3, conflict areas. Let's click no there. And now let's run our simulation. And again, if I did this correctly, vehicles should no longer overlap. And you can see vehicles waiting for each other to pass. And it looks good. Again, we've given priority to the vehicles on Kopik Road, the straight driving vehicles and not the turning vehicles. And so this takes us now to step 8, speed reduction areas. I feel that some of the vehicles are entering the corners too fast, which is not particularly safe or realistic. So in step 8, we will address this. For now, stop the simulation. Let's look at our reduced speed areas. But first, I can turn off the object visibility just to make it easier to work with our network. Then we will go to reduced speed areas, our next network object. Hover over a connector. Hold control, right click and hold. And much like drawing a link, draw a reduced speed area, which is shown as a yellow box. Let go of control, right click, and this window will open up. And this box essentially indicates the speed at which a vehicle should be driving at when it enters the yellow box. So here we can add, right click, add. So for cars, let's set it to 20 kilometers an hour because previously we saw vehicles cornering at 35 kilometers an hour, which is quite fast. Now click OK, and we've created our first reduced speed areas. Again, this should be done using real data based off of observations and measurements done at this particular location. But we don't have time for that, so we're just using this as a hypothetical example. And now we want to do this across all different connectors. To speed up our workflow, let's just copy and paste these. Hold control, left click and drag, and it will create a new reduced speed area. Repeat this process for all the other turning movements. We should have 4 in total. And again, now we can save as reduced speed areas, save, run a simulation. Let's see this in action. If I tap the spacebar and click on a vehicle, say this vehicle, on link number 1, here down in the quick view, I can see the vehicle speed right here. He's going at 50 kilometers an hour and he's about to enter the turn. His speed should slow down quite considerably. He's now down to 20, below 20, 19. Again, it's a vehicle speed distribution, so it's not exactly down to 20 kilometers. It's plus minus several kilometers. And now he's sped back up and left the network. Okay, let's stop our simulation. And one last thing I would like us to do is to update the vehicle composition so it better reflects the local Cambodian reality. And for one, this is very much a motorbike dependent city. The majority of vehicles are two-wheelers, whereas in our model, the large majority are private four-wheelers. Okay, and this takes us to step 9, creating a vehicle composition. We're now getting closer to something that looks like reality, but as you may have seen, the streets of Phnom Penh are full of two-wheelers and not four-wheeler private cars. So for this, we need to create a new vehicle composition, which is a multi-step process. This is in part because mopeds, the dominant vehicle type, are not a preset when you open Vism. However, Vism does have a big library of 3D models, which includes a moped. So first we'll need to load up this model into Vism so we can use it. And to do that, go up to Base Data, left click, 2D and 3D models. And so here you can see a list of all the different 2D and 3D models which come as presets in PTV Vism. This does not include a moped, so we'll click on plus. In your case, you may not already have direct access to them, so for this, click Open Directory of Default Models. Click on Vehicles, click on Road Vehicles, and here you will see a long list of different model types. I will use this scooter. It's an electric scooter, but I can change the behavior so it runs like any kind of scooter. But there's also many different object types. So you can look at these in your own time and or create more complex vehicle compositions as you wish. But for now, I'll double click on the scooter. I won't customize it, although I can. I'll click OK, and we'll call this moped. I prefer moped as a term for a scooter because you also have the standing push scooters. So now we've loaded up the model. Let's go back to base data. Now we go to distribution. We need to set the distribution of our 2D and 3D model. So click distribution 2D, 3D model. A new list will appear. Click add. Let's call it moped again. And in our list now on the right, let's load up the model. So the last one, 302 moped. And now one more step in base data. So click on base data. Click on vehicle types. Again, click add. Let's add our moped here. For category, it is a bike, it is a two-wheeler. And for vehicle model, it is a moped. Now click OK. Now we have one more step. I know this seems complicated, but once you've worked with this software for several days or weeks, this all becomes second nature. So now click on traffic. Now we get to create a new vehicle composition. So click on vehicle compositions. Click the plus to add. Let's create a vehicle composition for Phnom Penh, the capital city of Cambodia, where I'm currently living and simulating. Now, over here on the right, click add. And add, say we'll have 3 different vehicle types as part of our composition. The first one is the moped. The speed distribution of a moped is probably around 30 kilometers. We also have cars, so let's add some cars. They drive slightly faster, say 40 kilometers an hour. And then light goods vehicles, they would drive a bit slower, say 25 kilometers an hour. Again, this is all hypothetical. As for the relative flow, here I will input percentages. Let's say 88% of vehicles are mopeds. I'll put in 88. Then 8% of vehicles are cars, and the remaining 4 are light goods vehicles. So now that we've created a new vehicle composition for Phnom Penh for our simulation, we need to update our vehicle inputs. So in our network objects, vehicle inputs, which we used earlier on, here right-click and click Show List. And this we need to update. Our vehicle composition should be set to Phnom Penh. And so with that, we've created our vehicle composition. I suggest you save as. That's file number 5, vehicle composition. Save. And now, one final time, let's run our simulation, and we should see an abundance of two-wheelers. Yes. So congratulations, you have created your first simulation, which is somewhat calibrated to the local environment. Of course, there's much more we could have done. And what I'd like to ask from you now is that you take a screenshot of your creation, which we will ask you to share in the next unit. So I'm going to print screen and pull this up, even in PowerPoint or whatever tool you wish to use. Microsoft Paint, of course, works too. And here I have a screenshot. So if you can do the same, that would be greatly appreciated. So now over to step 10, which is where we can discuss the potential next steps. There's of course much more we could have done. We could have added different 3D objects for beautification, such as buildings and trees and benches. We could, of course, also have input different pedestrian areas where the pedestrians are walking and interacting with vehicles, so all the different crossings that we saw, as well as parking. I know there's parking on most of these streets here, so this is something we could have added in. And if the vehicles enter and leave the parking spaces, they impede traffic flow. So it's important to factor these if we want to create a realistic simulation. We would also then use this base model as the base from which we test different alternative designs. For example, building off of this, we could introduce, say, traffic lights and test different traffic signal configurations. Say fixed time traffic signals versus actuated traffic signals, which we can also do in Vizim. We could also say add a bike lane by removing a lane of traffic and use this tool to understand the impact this would have. And we can of course do much more and create a simulation for a much larger area, the entire island of Kopik, if we really wanted to. For now, we can leave it at that. This now concludes the Vizim tutorial. I hope you were able to follow along, and if you were, you can probably see that traffic simulation is quite fun. It's very visual and interactive, and we could really have spent an entire week, probably even more, just focusing on this particular tool. But the topic of transport data is so vast, so we had to quickly gloss over this topic. But if you do wish to continue your learning, I highly recommend you check out the PTV Academy. I'll provide a link below, which provides you with lots of video-based tutorials for their different tools. And if you do wish to continue learning tools like this, also let us know in the forum in the next unit, and we can maybe facilitate this in the future. And there, we will also ask that you share a screenshot of what you produced. So with that, I'll see you in the next unit.